Bear in mind that the dot is sometimes omitted. You can just use it as a dot. Without a dot b, you can use it as ab, as you all aware of it. And then the truth table shows that if the gates has low outputs, the value always shows you the false. The next gate. And over here, before I go to the next gate, the terminal A represents A dot and the terminal B represents B. So when these two are joined or multiplied, the output of the following will be A dot B. I hope you understood that. The next gate is OR gate. The OR gate, if you go through, it always has the output 1. Whenever the output is 1, whenever the output is 1, the input is 1, the output is always 1. Go through this section and then you will understand how plus is done. So the crescent and the terminal A plus B as it's shown here, and the plus is used to indicate the operating the OR gate function. I hope you understood this too. Next, the NOT gate or the inverted gate. Go through this statement and see how it is done, and you will see the picture. If you happen to find a dot in a circuit next to the circuit, you must remember that it is a NOT gate. I hope you understand this also. Go through your lessons and see how I have taught you. Next is the AND gate. As you are well aware of it, an AND gate is a collection of AND and a NOT. It means it is not AND. So the output, the following output of AND is not NAND. It's the NAND gate. It should be the NAND gate here. And then the NAND gate, here it says this is not NAND, it says, which is equal to AND gate followed by a NOT. So you should remember how the AND works. Next is the NOR gate. I hope you can remember it's not NOR. So we know that if output in the OR section, if there is a high output, the value is always to get as 1, but in this it's not 1, it's the opposite of 1, it's zeros. I hope you can understand that too. Now this is a gate that I have not taught you. These are two gates that are exclusively OR. I want you to pause this video and see what it says about it. It says that the gate acts as the same way as a logical either or. So the output is true if either but not both. Both, not the both. If there is a both outputs as equal as high inputs, then it becomes 0. So this is an exclusive gate, and it uses the symbol of plus around a circle, inside a circle. Next is NOT XOR, exclusively NOR. So go through this also. and see, pause a little while and see how the negative of the NOR, XNOR. And the most important thing for you to remember is that using combinations of logic gates, now we are going to combine logic gates, and there only you will find little hard. So let's do it in a practical way, so for you to understand. Complex operations can be performed. In theory, there is no limits of number of gates. Now in a circuit you will not only have one digital diagram, it can have many, as much as you can, to arrange it and to make a device to work. So I want you to just read this and then understand this, how it is done. Now let me come to the next session of how we do theory. The theory is given to you now. Let's learn how the practical is done. Thank you for watching.